Imagine our solar system with two bright suns in the sky instead of just one. In this crazy hypothetical situation, there'd be no more midnight sun or twilight. The days would be much longer, and the nights would be way shorter. And if you thought that meant double the sunshine and warmth, think again. There'd be some serious heat waves, but also a whole lot of freezing cold. That's because even if we doubled the number of suns, it wouldn't automatically mean double the heat. So what exactly would happen to our planet if it had not one, not two suns? Hey there, welcome to my channel. First off, let's look at what would happen to our solar system if there was more than one sun. Now, the sun is pretty massive, so adding another one like it would immediately change things. If we were to magically duplicate our sun and plop it down in the same orbit, we'd have a couple of problems. The first would be gravitational chaos. The main reason the planets stick around the sun is because its gravity keeps them in check. The sun's gravity pulls the planets in toward it, but they're going fast enough that they don't actually crash into it. They're constantly falling around the sun, and the further away a planet is, the slower it has to go to stay in orbit. Our Earth is about 150 million kilometers from the sun, and whips around it at about 27 miles per second. If we put a duplicate sun in the same orbit, the extra gravitational pull would mess up the speeds and paths of all the planets. Some might get flung out of the solar system altogether, while others could spiral into the sun. So right off the bat, we can rule out having two suns in the same orbit. Instead, let's imagine a second sun that hangs out farther out in space. For example, maybe it's twice as far from Earth as the sun is. This means our Earth would orbit around the center of mass between the two suns. And to keep things simple, let's assume they're the exact same size and mass. Since the distance between the sun and Earth is about 150 million kilometers, this new arrangement puts the other sun roughly 300 million kilometers from us. It's still fairly close, but it's far enough that the gravitational effects on Earth itself would be pretty small. Of course, the planets would still orbit the Earth, but now we'd see something really cool happening. Because the two suns are so far apart, sometimes the planets will pass in front of one sun, but behind the other. To someone watching from Earth, it would look like a brand new planet eclipsing a different star in the sky every single year. But even though it may seem like Earth would get twice as much sunlight with two suns, we'd actually get a lot less from one of them. That's because our sun's light takes about 8 minutes to reach Earth. We don't notice this delay because we're on the same planet. But if there were two suns, we'd be able to see the second one's light taking 16 minutes to reach us. Meanwhile, since the second sun is twice as far away, it would appear half as bright in the sky as the first one. This means that for half the year, when our Earth is orbiting closer to the other sun, we'd only get light that's half as bright and takes twice as long to arrive. All in all, the amount of sunlight reaching Earth would probably be about the same as what we get now, maybe a little less. But it's not just the brightness of the light that would be different. The color of the light coming from the other sun would be slightly different too. Stars have a range of colors from blue to red, depending on their surface temperature. Blue stars are the hottest and red stars are the coolest. Our sun is a yellow dwarf. But if it were twice as far away, it would appear redder to us. The other sun would probably be somewhat bluer, because it is emitting more light to make up for the fact that it is farther away. This means that when they're lined up in the sky, we'd be able to tell which sun was which based on their color alone. But the most noticeable change by far would be the length of day and night. With two suns, we'd need to divide a year into 4 equal seasons. Each season would be 3 months long, with 6 weeks each of spring, summer, fall, and winter. The longest day of the year would be during the summer solstice, when the sun reaches its highest point in the sky, and the shortest day would be in the winter solstice, when it is at its lowest point. The difference in length between the longest and shortest days would depend on how far apart the two suns are. The further apart they are, the smaller the difference. But if they were close enough, the effect would be extreme. In the northern hemisphere, the summer solstice could have days as long as 19 hours, while the winter solstice could have days as short as 5 hours. That's almost double the difference in daylight hours that we have here on Earth. And if the suns were even closer together, the difference would be even greater. But wait, there's more. Not only would we have these super long and short days during the solstices, but they'd also be reversed in the southern hemisphere. While the north experiences summer, the south experiences winter and vice versa. So for half the year, one hemisphere would have long days, while the other had short ones. Plus, there would be no more midnight or twilight, because one sun would always be in the sky. The only darkness we get would be in the few hours between the two solstices, when neither sun is high enough to illuminate the sky. All of these changes would obviously affect the weather. During our regular summers, the northern hemisphere is tilted toward the sun, meaning we get more direct sunlight and higher temperatures. The opposite happens during the winter. But with two suns, this pattern would be way more extreme. The summers would be much hotter, and the winters much colder. Not only that, but because the heat from the sun depends on how far away it is, the distance from Earth to the sun would matter more. Areas near the equator would be closer to one sun for part of the year, and the other sun for the rest of the year. They'd experience the most extreme temperatures. The poles, on the other hand, would be furthest from both suns for half the year, making them the coldest places on the planet. And even though the average temperature on Earth would likely stay about the same, the actual temperatures we experience would vary way more. We'd have more heat waves in the summer and more cold snaps in the winter. And since the difference in temperature between the two hemispheres would be so great, we'd see more extreme weather patterns like hurricanes, tornadoes, and blizzards. But all these crazy changes would only be temporary. After a few billion years, life on Earth would probably go back to normal. You see, stars aren't eternal. They eventually run out of fuel and die. Eventually, our sun will run out of hydrogen and collapse in on itself. If the other sun is far enough away, it might escape being pulled in by the collapsing sun. But if it's close enough, it might be sucked in along with everything else. In either case, the planets would get flung out of orbit and sent wandering through space. The sun's gravity is what holds our solar system together. Without it, the planets would just drift away. The idea of having two suns might sound fun at first, but it would actually make life on Earth way more extreme. Now watch. What if the sun went out? Or check out this video instead.